Hello everybody, let me start my presentation, which will be about SAP HANA Cloud and Analytics. I joined SAP shortly after I finished my university studies in Brno. My schoolmate told me that there is a free position there, so I joined SAP. But that time I didn't know much about SAP. I would like to ask you, do you know anything about SAP, what SAP does?
Management tool.
Sorry, management tools? Yes, management tools we have. We have a lot of things, several things you will see, but let me share with you just two numbers. 99 of 100 largest companies are SAP customers. 99 of 100. And the second number, which I was impressed when I was prepared, SAP customers generates 87% of total global commerce in the world. So you don't see us, but we generate, or our customers generate 87% of total global commerce. So if you drink water, eat chocolate, use your phone, drive your car, feed your pets, watching NHL, NBA, everything like that, there is SAP behind that. I don't know if you read the annotation of this presentation, but I mentioned there that information which we need, or you need, or customer needs, they would like to have them in speed of F1 car. And the second quote I have there, that you probably would not imagine that SAP is used by esports company playing Dota 2. I prepared two videos and I'd like to ask you, which one would you like to see? F1 car or e-commerce or e-sport Dota 2? So please raise your hand for F1 car video. I'll try to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, roughly. Dota 2. 1, 2, 3, 4, 5. Okay. Always the same results. I suppose nowadays you like to see Dota 2, but it seems F1 is still more fancy stuff. So I'd like to show you this video. Hopefully it works.
Meet the new Vodafone McLaren Mercedes MP428. Created by a team of 450 designers and engineers, it takes 80 personnel just to race it. Being first across the finish line requires more than flawless aerodynamics and legendary driving. Today, Formula One racing is also fueled by data. That's why Vodafone McLaren Mercedes looks to SAP HANA to accelerate analysis. Hundred 150 sensors monitor car and driver performance around every corner. These sensors track vital stats like engine performance, tire health, brake wear, and driver biometrics. In one lap, they will collect and transmit 2 gigabytes of data. In a single race, a staggering 3 terabytes. SAP HANA enables McLaren's existing systems to process this data 14,000 times faster than before. Analysis that previously took almost a week to process can be completed in the span of a pit stop.
So, as you saw in this video, probably you would not imagine SAP by F1 racing team. You would imagine we are in, I don't know, finance, product or management tools, but we also support F1 racing team, and as you heard, nowadays the cars are have more than 150 sensors, and in each lab it produces 2 gigabytes of data, which then reveals even 3 terabytes of data in single race. And before, the teams analyze the performance during the week. Nowadays, with our in-memory column store SAP HANA database, they can analyze it 14,000 times faster than before, so they can do it in a pit stop. So, sorry, the second one we will skip. So, let me introduce myself. I'm Radim Benek, a development expert from SAP Labs Czech Republic, located in Brno. We have in Brno research and development centers. We are, I think, 4th or 5th largest research and development centers from SAP around the globe. We develop, localize and maintain products. The products could be finance product, of course, but nowadays we also have, for instance, sustainability products, like your former student nowadays working in our sustainability team. So we have really various products. We also does the localization, which doesn't mean only translation of the product to all the languages, but also, you know, in all countries there are different laws, so it needs to be adjusted. And maintenance, if we sell our product to customer, the support doesn't finish. We are here for them to support our product. For instance, for S4 HANA, we promise the customer support it until 2040. In maintenance, I'm working for a different product. What will be content of our presentation today? We will look at data and analytics capabilities from today's perspective, and we, for that, we have 3 main products, which is SAP HANA Cloud. This is the database engine in memory column store database with other capabilities like machine learning, graph data, and so on. On top of that, we have our BI solution Data Warehouse Cloud, which consumes the data from SAP HANA, but also from other resources. This could be a single source of truth for all your data, and on top of it, we have SAP Analytics Cloud, which provide the reporting and dashboarding. Okay, so let's first have a look at SAP Cloud. As I mentioned, this is our in-memory column store database, which has, as you see in the video, tremendous performance. We will look at the performance in more detail. In the past, the computers has just one CPU, limited memory, and all the data were persisted in disk. And everything, all the database engines, always need to read the data from the disk to limited memory. CPU process it, then needs to read another data from the disk because the memory was not enough. So and so on and so on. It was quite slow. Nowadays we have multi-CPU, multi-core CPUs, really huge memories, and then the disk would not need to be as a bottleneck, because in the past it was always bottleneck. As I mentioned, you read the data from the disk to the memory to CPUs, and the processor works there. Nowadays, entire database could fit to the memory. like my computer here has 16 gigabytes of memory, and the servers could be really huge, several terabytes. So we have big memory, so we can get rid of data disk and put the data into memory. So if the database would be the same, in principle it would be, I don't know, 1,000 times faster because memories are faster. But we can go even further. As I mentioned, our database is column store. Usually if you have simple database, you can imagine it as a rows. So if you would store it in a row, let me show you. So if you would store this database in a row, so in the first row you see you have the name, team, and the bonus. Second row, again, another name, Bob A20, and so on. So if you would like to find any row in that table, I mean the whole row, it would be quite fast. So by an index or whatever, you find that, for instance, I would like to find a row or all the data set for the person called Bob. I would be navigated somehow, I don't know, by index or whatever, to row 2, and you see the complete row. But if you would like to, for instance, calculate the bonus from the whole table, you need to go to the row 1, find the 10, then go to the row 2, find 20, row 3, and so on. So you need to simply jump, or you will read the whole data set, the whole rows, find the last column, and read it. And for this, it will be slow. If we would organize data not in rows, but in columns, then this could have some advantages. And how it's organized, we store the column in one place. So we have column for person, and then we have the first person name, second, third, and so on, one after each other. For the team, we have A, B, I think A, and B, it shall be repeated here, I think it's not precise. And for bonus, it's 4 here. And back to my previous query, if we would be interested in all the bonuses, we simply jump to the bonus column, and we have all information at once, and we can read it quite fast. So the column storage is much better for analytics. So if you are interested in these analytics queries, the column storage is much faster. But if you would like to have transactional and analytics database engine in one place? Do you have any idea how this could be done? The idea is to have separate storages. So for the compressed data, for the data which are there for quite some time, we have the main storage, the column storage, which has all the data in columns, and then we can quite fast react on that or calculate the data. And for the data which we would insert into this database, it's quite hard to, not hard, but it takes some time to put it into the columns, because you will see more next slide. It will take some time. So basically we have the delta storage, which is row store data, and once the database engine has time, it simply compress, move the data from row store to column store. So with that, you have advantage of column store and transactional operations as well. So we have our data in memory. With the column store, they are quite fast, but yeah, you can also run out of memory even if the memory is now cheap or cheaper. And there is technique how to avoid it, and it's about encoding and compressions. If for example we have this table persisted, if this would be a row store, then we see in this table, for instance, Denmark is stored twice there, and it consumes twice, I don't know how much, it's seven characters, or if the code would be 10 characters, twice 10 characters. But you can save the memory with so-called dictionary. If you would build a dictionary of unique, for instance, countries, you would have the country there only once. You will put a number to it, and instead of, I don't know, 10 characters, these 5 numbers can be persisted in 3 bits. So instead of 10 characters, 10 bytes, you can store the same information with 3 bits. So then in the column, in row 1, you would not have France, but France is on line 3, so you will simply store here 3. Column 2, Denmark is, sorry, in column 2 it's Italy is 4, so you will have 4. So this is then much, you will save a lot of memory with this. It's not unusual that, for instance, you can save, I don't know, 90% of data of memory. So this is encoding, and we have yet another techniques which are compressions. If you look at this data, these numbers 3, 4, 5, 4, 2, and so on, there are compression techniques that even these numbers can be compressed to even smaller data footprint. For instance, if there would be a lot of, I don't know, Belgium, or sorry, 3 is France, a lot of France. At the beginning, there is a compression technique, run length encoding, that you will mention this, the value here only once, and then you mention how many times it's repeated. So with this, you can even shrink it more. So we have the data in memory instead of database, instead of disk. We store them in a column instead of row. So then the analytics are quite fast. With the encoding and compression, they even consume less memory. So with this, we have everything what is needed for quite fast database. Let me show you one example. Did you have already SQLs? SQL? Yes. Okay. You needn't to study in detail what it does, but simply there is SQL from any table. It's quite famous SAP table, AC.A. It's quite a huge table, a lot of columns, I think 400, 500 columns. And we have some aggregation like sum or count, we have where condition, we have group by, and we have order. Just to imagine how this can be used. And I tested it on our internal performance system, which, as you can see, it's a little bit bigger. It's 48 terabyte of memory and 1,100 CPUs. We test our HANA database in that system on real cases. So this is extraction of real SQL which is used in our application, and this is quite regularly tested. So I had access to that system in quiet period, and I executed the SQL there, and here are the results. So first of all, I did a copy of only 110 million of records from that table. It consumes only 5 gigabytes of memory. And now the question to you: how long do you think this SQL took? This, which I had before. So
20-30 minutes.
20-30 minutes. Other guesses? It's less, yeah. So
I would say it was less than a minute.
less than a minute. Okay, it's less than 2 seconds. 1.8 seconds. Yeah. 410 millions of rows. Now I did the same, but I organized the data in row so that to show you that our database is not fast only because everything is in memory, but because also of the of the structure of the table. So again, the same example, I copy it to the memory, to the new table called AC.A_R, like row, 110 million records nowadays, or in that time, you see, instead of 5 gigabytes, it was 240 gigabytes of memory. Same SQL, and the same question to you: how long do you think it took on this one?
5 seconds.
5 seconds?
Day.
No, 22 seconds. So everything was in memory, but you see that the column store is, I don't know, 10 times faster. Let's go farther. This is the original size of the table, 20 billion of records. This is, could be customer case. There are some big customers like, I don't know, Walmart in America. They use it quite heavily, and they could have 20 billion of records. I just have the column store because the row store will not fit into memory at all. So you see 1.3 terabyte of memory consumed, but the engine is quite big, 48 terabytes, so it fits there. And now the same question again. The last one.
Around 2 minutes.
2 minutes?
Yeah, around 2 minutes.
Quite close. 139 seconds. But you can imagine to process 20 billions of records in 2 minutes. It's quite fast. Here I have other examples, which I don't want to bother you, but maybe just focus on this one last line. We also have SAP HANA Express Edition, which is the same database engine. You can install it. I install it on my PC. You can do it as well. There are certain limitations, like I think the size of the database could be only 30 gigabytes, so it's not for productive use, but you can play around with that. I install the virtual machine. You can install, I don't know, Linux installation. So I just did only small portion, 5 millions of data, and it took 9 seconds, just for your illustration. So as you can see, this database is quite fast. Therefore, in the F1 they can get the information quite fast, as it was mentioned in a span of bit stop. Here it's mentioned that we offer for testing purpose the Express Edition. You will have the links in the presentation, so you can play around with that. But even you needn't to install it. Nowadays we offer also SAP HANA Cloud Trial Edition, and I will show you a short demo here with this link. You needn't to install anything. You in your browser you will have the trial account. You will choose if you would like to have this database in Amazon in Frankfurt, or in Azure in Singapore, or somewhere else. And you will create the database. You are able. There is also certain limitation because it's trial, not for productive use, but you can play around with that. The limitation is 3 gigabytes of main memory, 2 virtual CPUs, and 120 gigabytes on a disk. And once you do it, you can open it in the browser without any installation. you have the SQL console, you have monitoring, so you can monitor your database, what are the expensive SQL statements, what is the footprint, and so on. So with that, I can show you the now show it to you. Okay, I can do it like that. Once I find my mouse. Okay. Yeah, so once you log into this trial home, you can create a database, which is quite easy. It will take a few minutes, and then you can open either the Database Explorer or SQL Console, like I have it already here. So I will close it. And here we have the catalog, what it offers. Here are the tables. Here are all the tables, and you can really play around with that. So like you can drop tables or create tables. What I would like to show it to you. And yeah, you execute the statement, and you have here the outcome. For instance, which I would like to show it to you. I already created some database tables. Here are the rows, and you can see also already here the comparison. Like here is the table size. It's not the count, so here are the counts. Here are two big tables, which are 32 million of rows. And the big one is column store, the second one is row store. And as you can see, this consumes 44 megabytes, and this consumes 1.5 gigabytes of memory. So you immediately see that the row store is not efficient in memory, but sometimes it's also necessary to have it. What you can also see, and this is not what I would like to show it to you. As I mentioned, you have the columns, and the columns are compressed, and we have different compression techniques, and here in that table we list it, and here it's mentioned that this table store, for instance, has these columns, and here we have the compression algorithm. So the database engine choose different compression algorithm for different column to be most efficient. Then what I've mentioned here in this SQL, that as you probably remember in the slides, I mentioned that if we insert into database, it's quite it could be quite time consuming to organize the data in the columns. So we store everything in the row store next to the column store, and then once the engine has time, it merges to the column store, and then the information could be retrieved quite fast. You can leave it up to database system, but if you know that you would like to do it now, you can execute this merge SQL statement. And let me now show you the select. Yeah, it will be smaller. Yeah, but there is select some group by order from table big and big 2. And probably you remember big 1. The first big is the column store. The second big is row store. Yeah, here are the results. But on the results they are the same, so we are not interested in these results. We are interested in the performance. And here is the performance, and the statement took 129 milliseconds in the row store, in the column store, and 960 milliseconds in the row store. Yeah, roughly, I don't know, 10 times faster in the column store again. So, as you can see, the column store database engine is quite fast. What you can also see is monitoring. Where is it? Monitor. Everything is in browser. You really needn't to install anything. This was not what I was looking for. And here you have nice dashboard of the system itself, the CPU consumption, the footprint, the expensive SQL statements, yeah, and so on. Yeah, you can really deep dive into analysis, user enrollment management, and so on. As I mentioned, you have it for free if you would like to try it with this trial account. So this was it for our SAP HANA in cloud. Here are the resources if you are interested. In the first link there is open course in-memory data management. There it's mentioned all the technique in more details if you are interested in the compression, in encoding and stuff like that. First and second, you have the links to cloud trial accounts. It's you will simply register yourself with your email and you can create the database in a minute. If you would like to install it on your machine, then there is the link with the express trial. And finally, HANA Academy videos and help portal have all the source of information for that. So this was the SAP HANA Cloud. Any question to that? Before we jump to
Could we see
chapter.
a video of Dota?
Video of Dota. Okay. Let's see how far we are in the time, and then at the end I can play it.
Because yesterday they updated like all Dota after the match, and right now there is a lot of huge option to search all data, and I think like there is something with SAP.
Yeah, could be. Yeah, we are, for instance, supporting NHL or NBA with the statistics. So if you watch these games, so then these statistics are also powered by SAP. And the team we are supporting in esports is called Liquid Team. This is not known to me, but probably to you. It's known. Okay, let's jump to the second chapter. So maybe you remember we have these three pillars, SAP HANA Cloud at the bottom, which is the in-memory constant database engine. Then we have the Data Warehouse Cloud, which is our BI solution. And let's have a look why it's there. As you know, data could be quite scattered, and they are each application, each vendor has their own data in so-called data silos, and it's quite hard to analyze them for all the stakeholders, either top management, CIO, CTO, CFO, whatever, and also for the people who work, I don't know, with the production, supply, and so on. And there is nowadays also a lot of technologies which support these analysis, but the demand is quite high now, and there are really many more data in as compared to past, and even the people who support this technology are quite advanced in these technologies. Nowadays the technology goes to people who needn't to know these technologies, but simply offer them tools which they understand, and they can build their analysis themselves. How the system looks in the past, there was central company data in one system, could be a SAP system or other systems as well, and there is reporting on top of it. But as I mentioned, the data really grow exponentially, and I here have a note that by 2025 it's expected to have 175 zettabytes. It's quite huge. You know, today there's AI, Internet of Things. Every small device could produce data, and there are machine learning which could analyze them. So the data are quite different. And what also plays a role here, that nowadays the companies are moving to cloud. Instead of having their own system installed in their systems, they use it. They would like to have the cloud, because the cloud is accessible everywhere, and you can use other advantages like connections to other systems. So again, some research here that by 2022 it's expected that 75 of all databases will be deployed on migrated cloud platform. So as I showed you in the past, we had HANA Express Edition on your PC. Nowadays we offer also for you HANA Cloud trial. So how the systems looks today? We have the global data warehouse system here, but the source of information could be really where's the pointer? Here we have the data warehouse cloud system, but the source of information could be really scattered around the cloud or the customer systems. So the information could be in all the hyperscalers or other systems, and on top of it, customers would like to apply analytics. So how to solve it? These scattered data around we offer the SAP Data Warehouse Cloud, which can connect all these information, all these data providers. With this, you can unlock some insights which you would not be aware of, and accelerate your business at the end. So how it looks like, probably this picture is familiar to you. I showed it at the very beginning as part of it. So how it looks like, again we have the HANA Cloud at the bottom, which is our HANA database engine, which has data storage, but also some machine learning tools are available. On top of it, we have the Data Warehouse Cloud, which I'm now talking about, which has all the data which are scattered either around the cloud or other systems, and connect them to each other. And on top of it, which I will talk later, will be SAP Analytics Cloud. And there are different roles which access these systems. At the bottom, there are the developers which connects all these systems and find the source of information. Then once the data is somehow linked to the warehouse, there are data scientists who does the modeling with this data, and this could be also done with these data modelers who work further with the data itself, connect them, build some entity relationship models. On top of it, there are business users who doesn't need to know all the table names or whatever, because the data modelers give the tables or the connections or the models human names. And with this, the business users can build already the meaningful analytics. And at the end, there could be users in different line of business, like the high management or also the lower management or the operations. And the source of data could be either SAP data or also non-SAP data, like unstructured data, pictures, text, and so on. How it looks from architecture perspective. So in the heart of Data Warehouse Cloud, there is SAP HANA Cloud, which is a database engine with the in-memory capabilities. In the middle, there is space management, which organize the information in so spaces. You then need to administrate that, meaning you need to give users some rows who and what can access, and then you can model the data, connect them to models, and build some business model scenarios. And on top of it, there's the analytic tool, which I will talk at the end of this presentation. And you have 4 accesses to it. First of all, you need to integrate all the data. So once the data are in whatever system, either remotely or you can upload the file. Operate, meaning give users and give users their roles, what they can do. Manage, meaning modeling the data, and finally using Analytics Cloud. Let's have a look at the first integration, which means we need to integrate the data. So the business warehouse shall be the single source of truth. You need to map all the data or load them. There are, of course, different options. One is virtual access, which is, of course, the best if you need to have the up-to-date data, because the virtual access means the data are not persisted, they are just linked to the source system. It could be other HANA system or whatever. So you have no upfront data movement, so the data is not moved in upfront, but once you access it, of course, they need to be moved and calculated. can, yeah, this has the advantage the data are up to date, but as you can imagine, it would be slower because the source system needs to be asked for data. Second option is, yeah, quite similar. You can, say the system, tell the system, yeah, where are the source data, but you can tell it, please persist the data in the system itself. So, yeah, the advantage is obvious. It's quite, or it's much faster because you have the data inside. But they needn't to be up to date. What you can do, you can schedule task chains which update the data regularly. So depends on your case. Every day, every hour, whatever. Yeah. This approach can be also used if you have here some models which uses virtual accesses, but the target you would like to persist. So then the target of this calculation or joins or whatever can be persisted. The classical data integration, you can build the ETL meaning export, transfer and load into the system. You can have some graphical mapping tools, or you can also use capabilities of Python, for instance. Again, you can schedule this transformation in tasks, so you get the data up to date. And finally, the data could be read from external resources, like we have here all the hyperscalers like Google Cloud, Amazon, Microsoft Azure, and I think the last one was Alibaba. So you can really read the data from a lot of resources to build finally then the model inside this data warehouse system. So let me then jump to what other options we have in the integrate. Here are mentioned what I already told to you. These transformations could be, as you can see in the picture, really low code or no code. You join all the sources which you have from different systems. You can join them, filter them, union them, or whatever. The data source could be OData, remote file, or whatever, and you can finally, as mentioned also here, you can have also script inside this transformation. So if these capabilities are not enough, you can also call it, for instance, with Python. Last but not least, you can simply load also simple file to the Data Warehouse Cloud. So then you will have simple database table. And finally, as it was mentioned, you can have also external data sources, and this could be either commercial one, that there is a provider who provides you any source of information. I don't know, I saw there COVID-19 statistics, financial statistics, whatever. At the end you will also show that once you build all your data models, you can also expose it and offer it to other customers behind either for free or also behind any license. So you can also consume the data free of charge, or also with the license if necessary. So we have the data in our Data Warehouse Cloud. Now we would like to operate them, which means we would need some here we call it space management. We organize the data in so-called spaces, which could be either separated or each other could look at these spaces. It's then you also see how much the space is consumed. You can really look at the spaces like directories or whatever. And this, why we have it? Because we can then easily can do the administration and security. Administration means you can provide the users access to these spaces, these data with roles, or you can limit it, for instance, with the IP, with the internet address, and so on. You can also have auditing and resource monitoring based on that, so you know who access which data. Yeah, these two are our skill because these are internal SAP techniques. So we have the data, we integrate the data, we operate the data with the space management. We give the users, we create the users and their roles, and we can also operate them via monitoring, which you can see in the picture. You see the memory, disk consumption, the tasks which are, for instance, running when you replicate the data, so you have all the monitoring capabilities. We offer the Data Warehouse Cloud in these hyperscalers. You see we are around the globe. We support all the 4 main hyperscalers. Like in the first example I showed you, it was Amazon in Frankfurt. Then there was, I don't know, something was in Singapore. Here it's also Amazon. You see we support all the big ones. So we integrate the data, we operate the data with the space and user management, and now we would like to manage them. We would like to model them for the business users. And you see here they can be modeled by business analytics with the no-code or low-code, or then with the developer capabilities. So let's start with the low-code or no-code. You see you can model them with this graphical tools, as mentioned earlier. Easily you can connect them with joins, union, which is nicely displayed. If it's not enough, you can put SQL scripts, and so on. And for the ones who are power users, you can really deep dive to SQL statements and also calculation views very right, where there are really a lot of capabilities to build your data according to your requirements. How it looks like: you define entities, like choosing the source of information, either local data, local table, or remote table, or whatever. You build the model. You can do the data preview if the data are as you wish. And finally, you can create your story. The story is part of analytics, SAP Analytics, which I will show you later. And this is exactly the use part, where the data can be used. As you can see here, SAP Analytics Cloud, this will be the third part. but you can also use still users who would like to have it in Microsoft Office. So we offer the Microsoft Excel add-in for the Data Warehouse Cloud. Then it looks like the pivot table. So with the Excel you connect to Data Warehouse Cloud, and then you can does your analytics based on that. We also support this third-party consumption that you can use or expose the data in so-called business content for the others. So if I would sum up this Data Warehouse Cloud, what are the most powerful feature? Connectivity, not only to our SAP products, but to Microsoft, Power BI or any other hyperscalers. You have the space management, which means you have the data separated in spaces, give the user a right to access it. Then with no-code data modeling, you can model them, give them semantic layer, more nice names, so then the business user can understand them and consume them. You can publish them on data market, so the others can use it either for free or behind the license. With the openness, it's possible also to have external tooling like the SQL console and so on. And these are BW bridges, internal BW tool. And finally, at the end, you have the advanced analytics in SAP Analytics Cloud, which I will talk about it later. Again, here, as we offer the SAP HANA Cloud trial, we offer here also SAP Data Warehouse Cloud trial, which I will show you. Again, you have here, I think it's limited for 90 days. So you can again play around with the tool for free. Once you register, you get access to it. What I like in this approach is it's called guided experience. So you have, I can show it to you. You have some tasks which show you how to work with that tool. So let me show it. So it's really a guided tool. Where is it? Let me close all these. I will look in again to Data Warehouse Cloud. As you can see, EU10, so it's located in Frankfurt, but it's not necessary for you. And here is the interface to it. If I go home, it's strange. I was expecting, or at least this morning, there was here an icon which show you, which guides you, kind of. So I will show you in this Analytics Cloud later. So how this Data Warehouse Cloud works. Again, cloud tool. In the database browser, you have your own home screen where you can have all your recent data. For instance, here there is a pure database local table with the definition of it. It's quite easy to load it. And you can see the results here. Yeah, here is just the result. This also supports the remote scenario. So I here, for instance, have an address book in HANA Cloud in different cloud solution or system. And it can be pure remote scenario, virtual access, and the data remains in the source system, or you can have this stable replication, which happens now. So the data are replicated. If you would like to have enable real-time access, you can switch it this real-time access, and the data will not be persisted here. So either you can load data here via, for instance, import from CSV file. Here you would put CSV file, and the system will load it, store, I don't know, items, and the system will try to recognize the columns. And load the data. Okay, we'll discard it. So you can have either local data or remotely the data, and then you can also build the data models, which puts more data together with this graphical tool. You have all the resources, you can join them, filter them, and then here it's the output. And if you would like to use it, expose it for consumption, then you will switch it on this flag, and then it's ready to be used. And here are all the capabilities, like these inner joins and so on. So we have the data in the system. We can model them in these models. And finally, we would like to report them with the Analytics Cloud. So this was it for the Data Warehouse Cloud. Here are again references. Again, we have a lot of tutorials, online documentation, and what I would really recommend is this experience guide, which again offers you free trial. So this was all for Data Warehouse Cloud. Any information, any question to that? Except of Dota 2 video, which I will play at the end. And now let's jump to the final part, which is the SAP Analytics Cloud. So the data we have, but we then would like to use them, and the usage or the decisions are taken on different levels, on strategic levels, like CFO or CEO of the companies needs to analyze it, or in operational levels, so managers in the middle management, or also the tactical from frontline, or the workers also need to analyze and make some decision. And how it usually works: you have some question, you ask yourself, you would like to analyze it with some predictions. Based on that, you plan, supply, you plan other stuff. Based on that, you act, and finally you report, and this goes in cycle if the reporting fits to planning. For all these analytics, we offer SAP Analytics Cloud, which has the analytic capabilities here in the blue box. We divide it in three main areas: business intelligence, augmented analytics, and enterprise planning. And let's go one by one. So the first one could be quite similar to the data warehouse, which is data analysis. If we connect our analytics, SAP Analytics Cloud to Data Warehouse Cloud, you can join to, you can use the data which you have in the Data Warehouse Cloud, which are scattered, but you have them put them in a model in Data Warehouse, and you can use them in Analytics Cloud, and with the data analyzer, of course, you can analyze them if these are the data which you would like to analyze. Finally, in the analytics, you are creating so-called, we call it stories. It's not anymore any Excel tables or whatever. We put now all in nice stories, and these stories you will see later can be also analyzed with this Story Data Explorer if you would like to deep dive more in any part of these stories. How the story looks like, we have them in nice dashboards, which are really understandable, colorful, with all the not only table capabilities, but you see all the maps, all the colorful graphs, and so on. These stories are interactive and can be easily commented also. So you have some comment features. So this is really the outcome of the analytics. And not only analytics, but we also offer reporting, which is these dashboards can be reported, I don't know, in PDF or PowerPoint presentation with multi-pages, nicely designed. You can also send these reports with a schedule, I don't know, every morning. The managers has their reports in their inboxes. These can be also personalized and so on. What I like the most about the analytics is augmented analytics, mentioned here for everyone. You can of course build your own analytics yourself, but with this augmented analytics you can ask the system to do it. For instance, with this conversional analytics, you can ask the system, for instance, show me the gross margin for finished goods over time. You can really type it. The system suggests already which fits the most to your question, and suggest already the results or the tree which would fit to your question. And really, once you finish it, you have the results. Nowadays, we probably will hear a lot of chat GPT. It's not yet included in that, but it's also similar to automated insights. So you have nice graph, for instance, here, and you don't know why, I don't know, this graph is so by the sports is this and that. So you will ask the system with smart insight, and once you do so, on the right hand side you have the result again in natural language, describing, I don't know, the sports is, I don't know, this and that. We'll see it in the system. Automated discovery, so not only single task can be given for you with the system, but you can create the whole story, the whole analytics for your data. So you ask the system to generate all these nice graphs and all these nice perspective for your data model, and you will have the story prepared for you. I will show you later. And predictive analytics, you can run some in planning some regression to give you a forecast. Here are all these augment analytics in details, as I mentioned already. So the search to insight, you write some text. For instance, here show top 10 airfare vendors with highest spend. You type it, and the system immediately show you the graph. Well, very nice feature for everyone. Smart Insight. As mentioned earlier, you are interested about one particular information, you don't know why, so you ask the system to analyze it in more detail, and the system explaining again, try to explain in human language. And Smart Discovery, this is completely auto-generated with machine learning, the whole story. So you have your own data, any data model, and you ask the system, create all the story for me, and with I think 3 pages you have really nice analysis of your data model. And finally, time series, which are the forecasting features. You have some graph like here, and you ask the system to forecast it kind of automatically. But enterprise planning, it offers the analyze and predict for all the key figures you are interested in. Here I have one example. As I mentioned, we support 87 of total global commerce. One of our customers is La Roche, which they with 2 hours they are able to generate 4 billion financial forecast in which they did in several weeks in the past. Also other usage which I like better because I'm kind of sportsman. San Francisco 49ers, they use the SAP Analytics Cloud dashboard to analyze all the data for their fans and so on. Again, as Data Warehouse Cloud, also here we offer a SAP Analytics Cloud add-in for Microsoft Office in Excel, where you can play around with this if you are still Excel guy. And finally, once you build your story, again as Data Warehouse Cloud, you can publish it for others, including licensing if you would like to have license behind that. Last but not least, of course, we enable Analytics Cloud Mobile, and as the screen is not so big, you can type the questions like in search inside. So with natural language, you can type the questions and you have the results. Again, as you can see, we are all around the globe, all the hyperscalers, so you can have the Analytics Cloud in any location. And finally, in the dashboarding, if you have the story, you can also comment all the features, all the results you have there, and really exchange information with all the other stakeholders. So, final slide by the SAP Analytics Cloud. You can analyze, predict, and plan all the data which you collect live, and you can collaborate with the others, and you needn't to install anything because it's cloud software as a service. Here are again information where you can use and where you can learn. One of it is again SAP Analytics Cloud Trial Edition, which I'd like to show you here. It's again guided experience. I don't know why it wasn't in the Data Warehouse Cloud, but once you will log in again for free 90 days, you can play around with that. And as I mentioned, it's guided experience. Here you have you can start working with this guided tour with the application overview, and here the system tells you how, if you would like to create, click the main, and you can so it's not video, it's really the system which reacts on that, but this guided experience tells you how to do and what. So let me close it to you, and let me show you how the story, which is really the end of our work today, how it could look like. Really nice graphs which you can use here. You can comment on that. You can deep dive into it, and so on. What I liked, and as I mentioned, we have the smart insight. You can ask any question in show up or question. Show sales manager, sales by manager. Show sales. Type it correctly. Show sales manager by, I don't know, target revenue. This was not what I was looking for. Manager. Show here you have nice graph, and with this you can put it into your story. And last, what I would like to show you is this smart directory. So here you have quite a nice story, which it's already there, but you would like to have more, and with this smart directory, the system automatically generates, which I already did, these 2-3 pages with machine learning, what are the key influencers, and kind of simulation and so on. So with that was all from my side. So I'm open for your questions. So if you have any question, you can reach me on LinkedIn. If you are interested about SAP positions not in Brno or somewhere else, you can use this link, and now I'm open for your questions.
Any question? No question?
Dota 2. Right. I promised the Dota 2. Okay. Nice remark. Again, so last 2 minutes. Let's jump. There it is.
Team Liquid did not start as a big master plan at all. It's just a story of following your passion. Nowadays, Team Liquid has grown so much, so we rely on our managers, we rely on our coaches, we rely on our players, and they have the know-how and insights to understand, like, when do you make a change, how do you move forward from there, and how do you dive into the details, how do you find the 1% or 2% improvements. And that's what we try and search for, and that's what a partner like SAP helps us in.
There definitely has been times where the tool has inspired us in very crazy ways.
But he still sent to the grave. Team Liquid is done. And
We had drafts that the tool suggested to us, which we would have never thought of. Thanks to the analytics tool built on SAP HANA Cloud, I actually do not have to choose which games are going to be important, because every single official tournament match will be put into the database. Now I can just click one button and suddenly everything's there for me. So time spent and efficiency is like the biggest difference. One big challenge was the time constraint you're under when you're at a tournament. It's pretty hard to pull out data and information out of games really quick in real time. Those problems have been a lot easier ever since.
this is looking fantastic now for Team Liquid.
The software that we are making for the esports scene is running on the SAP software that already exists, like the business technology platform and SAP HANA as a database. So in the analytics tool there are different features. They really can use it for every game, also in the training, so that it's end-to-end supporting them in their whole process of being a team and competing in tournaments on a high level.
Data and information are absolutely crucial in esports. They're crucial for our business, our company, our competitive teams. You've got to be able to show people the data and the statistics and the information to support your decisions, and that's the way to build momentum.
Okay, that was it. Thank you.